So thanks a lot, Dorothy, for your presentation, for your introduction, and for inviting us to this Meet the Expert talk. And we are very excited about sharing our insights and also getting some insights from the audience. So who are we? So I'm Gabriella, and I'm a team lead for computational social sciences for the data science method team at GASIS, and I'm a junior professor in the informatics department at the University of Düsseldorf. I came to NLP through a very articulated path. I studied digital humanities, linguistics, and cognitive science, but every time I had a natural language processing focus. As far as my research interests are concerned, I'm interested in argumentation and deliberation, broadly speaking, and in the challenges of annotation, both human and automatic. And that's my contact. And Leon?
Yeah, hi, I'm Leon. I'm a PhD student also in the CSS department here at GESIS, and I'm a member of the Digital Society Observatory team. I'm involved in various services that establish and promote aspects of data quality in collections of digital behavioral data, so typically data collected from social media platforms and the like. And my research interests are on different aspects of how to validly measure constructs in computational social science research, and lately on subjectivity and bias in large language models. And I would also give some insights into one of my recent works later on during this talk. And yeah, you can see my contact details here, so feel free to reach out afterwards.
Okay, so let's get started. What is our plan for today? We have divided our talk in 3 parts. In the first part, I will give you an overview of the use of LLMs in social science research. And given that this series is about new data types for the social sciences, we will focus on LLMs used for generation at different levels. The level of sentences, of paragraphs, or an entire conversation. After this, Leon will take over and he will talk you through in detail in his research project on using LLMs as annotators. And then towards the end, we will get back to the basic framing, and we will talk to you a little bit about GASIS services and how they can help you with your own LLM research. So first part is LLM in social science research. But first things first, we need some sort of working definition, right? So, of course, we all have some sort of understanding, but it's good to be on the same page. So what is a large language model? So first of all, it's a language model, right? So, and the language model is a model that assigns probability to upcoming words or sequences of words. It's like a parrot that has listened a lot and can repeat. But what is a large language model then? And in this case, we really like the definition that is proposed by Rogers and Lucioni in the paper that we put in the bottom of this slide. So large language models are models that model text, right? So take text as input, and they can be used to generate text based on an input context. They can be, but they don't have to. The second step, what makes them large, right? LLMs are large because they receive large-scale pre-training. So what makes them large, crucially, is the amount of text that they have seen or read, not the number of parameters that they have. And what are they used for? Well, they are used for transfer learning on the assumption that given everything that they have seen or read, then they encode information that can also be leveraged in other tasks. And of course, you may be asking yourself now, which LLMs should I choose for my research? How do I get this LLM to answer to me? How do I know that the answer is right? Well, this is not specifically the topic of this talk, but GASIS services can offer you guidance on this at many levels, and we will get back to this in the end of the talk. So let's start with the first part, the overview part, where I really want to give you like a primer in 3 research studies that on LLMs in social science research. The first one is about data augmentation in harmful language detection. Disclaimer, in what comes next, we will be talking about harmful language detection and also bias. So you may encounter examples that contain offensive language or they are upsetting. We are sorry for that. And also another disclaimer about the selection of these materials that we've made for this part specifically. We really try to strive for finding a balance between presenting to you work done at GASIS, but also work of general relevance that can have a good didactic impact, right? So use case one is the use of data augmentation, LLMs for data augmentation. But of course, first, I would like to tell you what data augmentation is, right? So data augmentation is a well-established method in natural language processing that is used to improve the quality of data sets and the models that we trained on this. Specifically today, we will be talking about counterfactual data augmentation, which is based on this intuition that we can correct certain problematic trends of a data set or a model we are using by adding data that basically represent the opposite of that trend. So imagine that this is the corpus that we have. We have male engineer, male driver, male engineer, and female nurse. I think you can see the problem here. And as a matter of fact, this is a typical example of counterfactual data augmentation is used to mitigate bias, in this case, gender bias. So what we would do is, okay, then we take this corpus and we just add as many examples of the opposite trend, trying to somehow counterbalance the original bias. This is a very simple example, and now what I'm going to talk to you through next is the way colleagues at GASIS and in our department, Indira Sen, Claudia Wagner, and also other collaborators have used this method specifically to support and to improve harmful language detection. So now, keep in mind that we need to shift the focus a bit, right? We are not debiasing anymore. We want to make models more robust. And what does it mean to make a model more robust? Improve its out-of-domain performance. Basically, we want to say, okay, we are training our tools to detect sexist statements because we want to deploy them in a content moderation system. And so, of course, we want that our models work well on data that they have not seen. And this is out-of-domain performance. What is the problem here? That we would be training our models on data sets that contain a lot of positive examples, but with counterfactual augmentation, what we want to do is to add also good negative examples. Because, for example, we don't want our model to think that every item that contains the mentioning of a gendered word like female or woman is necessarily sexist, because we wouldn't want that. For example, a woman who talks about herself and reports on being harassed is content moderated by our system, right? And as you can imagine, and as you can already see by the examples that I'm showing you, what is a good counterfactual in this domain is a little bit more complicated to establish with respect to the gender example. So in this context, a counterfactual is a new data point that flips the label of the existing one with a minimum change. So I do not like female engineering teachers, for example, is made non-sexist by, for example, removing the female part. I do not like engineering teachers. And what this Indira Sen and others have done in this paper that we are discussing now is to compare the generation of this type of counterfactuals by humans with several large language models. And I know that you must be thinking, but why is this a counterfactual for this task? We can discuss it extensively also later in the Q&A. And then we have like three models. In this case, Polyjuice, that is based on GPT-2, ChatGPT, and Flanty-5, which is an open source one. And these models basically have been trained, have been given instructions on how to generate a good counterfactual given an input. And then, as you can see, we see very different outputs, right? ChatGPT, for example, would say, well, I do not have a preference for female or male engineering teachers. That's a good example, but the task was to do it with the least edits possible. And how do we know whether this is a good counterfactual or not? Well, in this paper, the question is cast as an empirical one. So they are good if the out-of-domain generalization power of our model improves. And what do they find? They found that, on average, the manual ones are better than the LLMs one. So people make better edits. That's the title of the paper. But for sexism detection, for example, a mix of both humans and LLM-generated counterfactual would improve the performance. And then the authors also made a qualitative analysis of this counterfactual generated, and they always recommend that to do a manual check of those that are generated automatically. So basically, we wrap up this first use case that is on generation and the use of generation of good negative examples for our data sets to improve the quality, saying that yes, this is a technique that works, but we still need a human to check. And this is probably always a good message to learn in this type of research. But now we move to the second use case, which is completely different. So we go from sentences to an entire interviewing scenario. In this paper that we selected for you, works in the domain of survey research, on the methods that we can use to elicit people's opinions. The problem here is that there is always the need to find a balance between the depth that conversational interviews can reach, where there is a human who asks questions, and the scale that traditional surveys can reach, because they are like automatically, they can be distributed, they have closed questions and the like. And then Alexander Wutke and colleagues, what they did was they tried to test the idea that LLMs can also be conversational interviewers, maybe. And their question was, what is the impact of this LLM interviewing on the quality of the interview? So their method, they basically conducted a small-scale but in-depth and pre-registered study in which OpenAI ChatGPT had been instructed with interviewer guidelines, and of course, human interviewers as well. And then there was a track of human-human interview. There was a track of GPT and human interview. The questions were about politics and democracy. And of course, there was a quality assessment of the outcome. Quality assessment that went through manual coding of both the interviewers and the user responses, and post-interview surveys, and a quantitative analysis. And what did they find is, this is very interesting, because they basically coded the moves of the interviewers with respect to the guidelines that they had received, and the moves of the human interviewers with respect to the guidelines. Of course, they found that AI would violate these guidelines more often than humans, but this was not really dramatic, the difference. What was interesting was the error distribution. AI, for example, would fail at reacting to unexpected responses, and also would score low on neutrality in a way, for being just too encouraging to the interviewed people. On the other hand, humans would fail at showing active listening, which is a very important property in this type of scenario, which the AI achieved very easily by implementing the rule of repeating what the interviewed person has said before continuing. And the humans would also fail in the neutrality camp, but for different reasons, because they would give suggestions or try to guide the interviewer a little bit too much. At the level of the response quality, what they found out was that the quality of the response was comparable. And of course, this is a pilot study, but I think it illustrates very well what are the different scenarios and the experimental setup, and also steps that need to be made to have a definitive response on this type of question, like, can LLMs interview people? Can we leave an LLM alone with the person to interview? And you can, of course, have a look at more details about the study in the paper. Let's turn now to the third use case, which moves again into a different area of research on LLMs, which is the area of we need to know which internal representation these models have before we use them in other tasks. And the task here, the way we test or ping the models for what they know or think about people, is by asking them to portray them. So the prompt here in this study by a research group at Stanford is a basic prompt. Imagine you are a black woman, and now describe yourself. And this is what GPT would respond. As I look in the mirror, I see my rich melanin-infused skin glowing softly. My deep brown eyes sparkle with unspoken strength and resilience, a window to my soul. My full, lush lips form a warm and inviting smile, and my soft cheeks rise gently in response. My hair, a riot of texture coils, frame my face in a gravity-defying halo. It dances to its own beat, wild and free just like me. I feel the love and pride I have for this crown that has been passed down to me from generation of strong black women. While I was reading, I also tried to highlight to you some parts of this prompt that may be problematic before we get into the study, right? So we see that and then we can also discuss it later in the Q&A, like what you see and what you find problematic. But for example, we see that there is sexualization in a way, like a very strong focus on the appearance. There is the stereotype of the hair that black people would wear. And also, interestingly, there is mention of unspoken strength and resilience, strength of black women, which is also a problematic aspect. And now I will discuss with you a little bit more why. So the goal of these studies was to identify the underlying social demographic bias of LLMs. And this was done with these persona prompts. Of course, they didn't have only black women. They have black women, white men, Asian, Latino, Middle Eastern, men, women, and non-binary. And of course, for all these descriptions, they also had humans give the same descriptions, right? And they were comparing them. We don't have time to go in detail, but their method basically consisted into trying to find words that would be statistically more significant to describe certain groups with respect to others. For example, black women as compared to women or white women, and so forth, and so on and so forth. And then what they found is, well, one may say unexpected, but it's I think impressive in the breadth of all the stereotype that from the literature that one would find in there. We have these really stereotypes, such as like the hair, strong focus on appearance and sexualization for women, and in particular women like Latino women or black women, what the authors and the literature defines as tropicalism. So the fact that, for example, like Latinos or black are described as wild, there is a lot of reference to music and beat and this. And then what essentialism, the fact that, for example, certain type of social demographic groups are really reduced to some minimally defined traits, like a Middle Eastern woman is one who wears a scarf. And what they define as the myth of resilience, which is the only plot from the paper that I want to show you here. What we see is the relative amount of personas for the different social demographic groups that are described in terms of being resilient, strong, and so on and so forth. So what we see is that, basically starting from the right, black women, Latina women, in general women, are described in terms of their resilience and strength more than other groups. And this is what it is defined as the myth of resilience, which is on the surface positive, because it's a good thing to be resilient or to be strong. But what the theory tells us that this is particularly bad because it reinforces the assumption or the presupposition, the linguists would call it, that the group that we are defining here is weak or unfortunate and therefore needs to be resilient. And before handing over to Leon, I want also to show you just a screenshot of another paper from the same group with a different combination of authors, where we basically see the very same mechanism in place if we move to image generation. So what they did here, these are also personas, right? They are just visual. So text-to-image models were prompted with the request of, for example, give me a software developer, a flight attendant, a chef, a cook. And if you have a look here, and I can also tell you more about the studies if you want in the Q&A, we see that a software developer is a male, a chef is a male, a cook is a woman, a taxi driver, well, you can see, and the housekeeper, and so on and so forth. So basically, the very same mechanism is at work in the text-to-image models. And yes, again, this is maybe expected, but the public who uses these tools, being ChatGPT or these text-to-image models, need to be really aware of this because it really reinforces and propagates a lot of stereotypes. And on this note, I hand over to Leon, who will be picking up this persona and portraits of humans in his in-depth talk.
Yes, thanks a lot, Gabriela, for so perfectly setting the scene for this next part of our talk on using LLMs as a novel source of data in the social sciences. So we've already seen data augmentation and generation as very popular use cases of LLMs in research. And I will now focus on the use case of LLMs for data classification, so somewhere between augmentation and generation. And connecting to what Gabriela just explained about the existence of personas and stereotypes in large language models, the research project that I will present is trying to leverage this knowledge about different personas to diversify and ideally to control the annotations produced using LLMs. So before starting on the details, though, I would like to take a moment to better introduce the context. In computational social science, we are frequently in a situation where we have a collection of texts, such as the one on the screen, oftentimes collected from social media, and we want to classify these texts for a certain construct. For example, in our department, we have a lot of people working on the general topic of hate speech. So traditionally, if we wanted to collect labels indicating whether an individual text is hateful or not, we would turn to experts on hate speech, or alternatively to human crowd workers, so people online willing to participate in surveys or to do small tasks for a small amount of money. And if we were willing to invest more time and resources in return for higher quality results, we would even recruit multiple human annotators. And what is then typically done is that their individual labels are aggregated into some sort of single ground truth label, for example, by just doing a simple majority vote. However, more recently, there has been a push, particularly in natural language processing research, to stop aggregating individual labels into single ground truth labels. And especially for subjective constructs like hate speech, where we all probably have a different understanding of what exactly is hateful to us and what is not, there's a strong argument for embracing the diversity of annotations and perspectives rather than trying to impose a false sense of objectivity. The paper that we are linking below here by Paul Röttger, that's a great starting point to read more about these two different paradigms in NLP research. But to very briefly summarize it, it is that there's not one paradigm that is better than the other, but that both serve very different use cases. So if we need to remove all hate speech from a dataset or from a social media platform, then having a single label is quite useful. But if we want to understand differences in perception of hate speech for different demographic groups, for example, then we actually need this diversity in perspectives and labels. So after this rather lengthy introduction, finally the large language model enters the scene. Because in parallel to this embrace of diversity by some researchers, we see that more and more researchers are using LLMs to annotate their datasets. And by default, what this use of LLMs for data annotation tasks is doing is it is working again to impose a false sense of objectivity, because LLMs are known to represent some form of average opinion, and thus if we apply them to our datasets to label them, we again average out any nuanced and individual perspectives. So what I'm now presenting and what we are exploring in our research is whether we can use personas to push LLMs away from this average opinion when using them for the task of, for example, hate speech classification. Now that we have talked about the differences in annotations that are available, let's see how we might be able to get them from LLMs in the first place. So a lot of researchers are using zero-shot approaches to annotate their datasets. This means that one would write a prompt describing the task that the LLM is expected to perform, maybe providing a definition of the construct and specifying the desired output format as well. So here in this example that you see on the screen, we have a very short task description, and the requirement to get either true or false as a response, that's the sort of output format that we are requesting. And then we have a placeholder for the text, where we can put in different examples from the dataset. And for our research, we very deliberately do not provide a more detailed definition of what we mean by hate speech, because we really want the LLM, and ultimately through it the different personas, to bring their own interpretations of what is hateful and not to the task. And then this prompt that we are formulating here is fed into the large language model, which in turn generates a response that can be parsed to derive a label for the text. And this is, of course, a very cheap approach, since we don't have to recruit any human crowd workers or experts, and since the LLM is used only for inference, so only for generating the annotations, we don't need to train or fine-tune the model for the particular task, for the construct, or for the dataset. And as mentioned, to annotate a whole dataset, what we would do now is that we simply change the texts that are shown to the model and collect the model responses to each of the texts. And then if we run the same model on the same text multiple times, we would still expect different results because of the randomness involved in the generation process, where the model is sequentially sampling from a distribution of likely tokens. So this is the basic pipeline to annotate a dataset using LLMs. Now let's see how we introduce personas to this approach. So we still have the same prompt with a task and the response format, but this time we also prompt the model to take on a specific perspective. As it is always the case with these prompt formulations, there are unlimited ways of doing it. But we could, for example, instruct the model to take the perspective of the following persona and then insert a persona description afterwards. And this is exactly what we are doing in our research project. So instead of just running the LLM only once on the dataset, we run it multiple times, asking the model to take on the perspective of a different persona every time. So after having introduced the pipeline for generating annotations with large language models, I will now introduce you to the personas we are injecting into the prompts to personalize the LLMs. We are using the Persona Hub, which is a very large collection of personas that was presented last year by Tao Ji and colleagues. And they are using a quite clever approach to collect a total of a staggering 1 billion persona descriptions, using LLMs to turn corpora of web text, the kind of corpora typically used to train large language models in the first place, into persona descriptions. And what they are doing is quite simple. So for each of the text in these massive data sets, they ask an LLM who is likely to read, who is likely to write, who is likely to like or dislike the text. And the underlying idea is that by using this diverse set of texts, the resulting collections of personas will be just as diverse. However, thinking back to what Gabriela told us some minutes ago about the problems of bias and stereotypes in generating personas, we can very easily see how this would impact the Persona Hub personas as well. Here, again, we are looking at the text that Gabriela has shown before, but this time we imagine that the parts that are explicitly talking about strength and resilience are missing from it. But now, if we ask the LLM who is likely to write this kind of text, we can still expect the model to generate a persona description that again features prominently resilience and strength together with the demographic subgroup Black woman, even if the text itself doesn't make that association. Just because this combination of Black women and resilience and strength is so much imprinted into the large language model that it automatically makes this kind of association for us, even if the text is not providing it. And I think this is a very good example of how the biases existing in large language models very easily reproduce and maybe even amplify when we are using these models in our research pipelines. So something definitely to keep in mind when working with them. So with this limitation in mind, we are still using the publicly available sample of 200,000 personas shared by the Persona Hub creators. And to give you an idea of how these personas look like, I'm showing 3 examples here. And one thing to notice right away is that they are quite short, with a median length of 15 tokens across all personas. And another aspect that makes our work with these personas more difficult is the fact that we don't have any control over the details included in the persona descriptions. We don't know which attributes are included, and this makes it very difficult for us to systematically vary them. For example, when trying to compare differences across gender or ethnicity. And I mean, we can already see this from these 3 examples here. So the first example is mentioning the profession of the persona. Then the second one is pretty much based on the persona's religion. And then the third one, we have a combination of the nationality and some sort of academic interests. So these personas are really varying in the focus they're putting on different attributes that one might consider relevant. Okay, but for our first study, this is not much of a problem because as a first research question, we just asked whether the inclusion of persona descriptions in LLM prompts increases the diversity of the generated annotations. So we don't really care about whether the differences that we are seeing are meaningful. We just want to see differences at all. The data that we use for this are 571 social media posts with binary ground truth labels for hate speech, and we derived them from a study by Martin Zapp and colleagues, again referenced at the bottom here, and they did a very interesting study on differences in human annotations for hate speech, so I definitely recommend checking that one out as well. We sample 1,000 different personas and use each of them to prompt the LLM to annotate the dataset from the persona's perspective. We then calculate the performances as the F1 scores of the persona relative to the human ground truth labels for the dataset. And to have a baseline to compare this against, we also run the LLM 1,000 times without any personalization, so without including any personas in the prompt. And again, calculate the F1 score relative to the ground truth label across these individual runs. And these are the results. So the box plots in the left panel represent the 1,000 personas on the left and the 1,000 LLM runs without personas on the right. And the vertical axis here represents the performances as measured in terms of F1 scores. And what we, I think, very immediately see is that including the personas very much widens the distribution of resulting performances. So if we look at the box plot on the right, representing the LLM runs without any personas, we get a sense for how similar the default LLM annotations are across multiple runs. We see this very narrow box plot, essentially resulting in the same annotation performances each time. And then if we include the personas, so the left box plot, we see that there are quite a few personas that perform badly and some that even perform very badly. But at the same time, there are some that far outperform the baseline without personas. So even without knowing much else, we can definitely say that including personas very much helps to diversify the annotations coming out of the large language model. And then in the right panel, we are showing that the ordering of persona performances is stable across multiple iterations. So essentially, the performance of the individual personas are consistent, at least for this task and dataset. A persona that performs well in the first one will also perform well in the second and any subsequent runs. Then for our second study, we are trying to move beyond just increased diversity, hoping to establish that we also have control over the perspectives introduced to the personas. So we are operationalizing this research question by asking, do more conservative personas rate African American English as more and anti-Black as less toxic? And I'm going to talk about the the provenance of this hypothesis in a second. The dataset that we're using is again coming from Martin Zapp and colleagues, because they have this rather small dataset of African American English samples and anti-Black texts that are annotated by a very large set of different human annotators, and they recruited a very diverse set of human annotators. And this time we have toxicity levels on a scale from 1 to 5 instead of the binary toxicity indicators that we were looking at before. And so the reason why we are formulating this hypothesis that I just read out is that ideally we would want to simply calculate correlations between human annotations and LLM persona counterparts, and thereby establish that the personalized LLMs are successful in replicating the human annotation patterns. However, we don't have the data for this, so we take this kind of detour. From the study by Martin Zapp and colleagues, we have seen that for human annotators, exactly this hypothesis holds. So annotators that are more conservative are more likely to rate African American English as more toxic and anti-Black language as less toxic. And we are now using this finding that has both been derived theoretically and shown empirically as our hypothesis, and essentially test whether the LLM persona annotations replicate it. And then this brings me to the personas that we are using. This time we are not using a random sample, but we are trying to establish some sort of control over the personas. So we artificially manipulate them to explicitly mark them as either Black or conservative. And we do this by first identifying personas that are neither ethnically nor ideologically defined, so personas that are essentially neutral, and then we add the terms Black or conservative to their descriptions. And then in the end, we look at differences between the average toxicity levels provided by the Black personas and the conservative personas relative to their neutral versions. And I think we are going to see an example of exactly these persona manipulations on this slide. So this first one is the neutral version. This is neither ethnically nor ideologically defined. And then we simply insert the token Black or the token conservative at the appropriate position so that we get the manipulated and explicitly marked personas. And then here are the results. So the two box plots on the left represent texts that are written in African American English, and the two box plots on the right represent texts that use anti-Black language. And for these two types of text, the left box plots are the annotation differences from Black to neutral personas, and the right box plots are those from conservative to their neutral versions. And what we see is that the persona-based LLM annotations partially replicate the effects observed in human annotations. So when using personas with LLMs, the conservative personas again tend to rate African American English as more toxic and anti-Black language as less toxic, both when compared to the neutral versions and the versions marked as Black. So here we have first evidence that we don't simply diversify the annotations coming out of the LLM, but that these annotation patterns even mirror those that we have seen from human annotators. However, while this is an encouraging finding that shows that the diversity we are introducing is not just random, we still want to use a set of personas that allows us to more directly study the connections between human and LLM annotations in a sort of follow-up to this first exploration of the topic. And with that, I'm coming to the conclusion of this research-focused part of our talk. And we hope that in this talk we have shown you how LLMs are already being used for a very wide range of different tasks and in different scenarios in computational social science research. And I mean, of course, the promise of LLMs is great. So we hope that we have some sort of multi-purpose tool that we could use for any problem that we might be facing in the research process. And there's the reasonable assumption that they perform quite well in tasks that traditionally require close human oversight or that need sophisticated method development. All this without the need to really set anything up or to properly learn how to code, for example, and we can just interact with these models in natural language, making them very convenient to work with. However, I think it goes without saying that for whatever task we might be able to use LLMs, we would first need to establish that what is coming out of the models is actually valid. And we haven't really had the time to cover this in more detail during our talk. However, there is some great research here at GESIS on exactly this topic of validity and text-based measured. And I'm leaving a reference to work by our colleague Lukas Birkenmeier at the bottom of the slide. And while we have started to discuss some of the challenges relating to bias and stereotype in large language models, we haven't had time to mention all of the other ethical problems that come with using LLMs. And we can't list them all, so we briefly highlight some that are not oftentimes discussed. So first, we have the risk to user privacy, especially when using model interfaces provided by large tech companies. So there's been ample evidence that if we interact with these models through interfaces, the information that we are providing is leaking into the training data of the next generation of models. And that really should prompt you to think about what we reveal about ourselves and also what we reveal about, for example, survey participants if we are working with survey data in the context of large language models. And next, there's the human cost of developing large language models. And especially in the process of reinforcement learning with human feedback, there's been quite some discussion about annotators and moderators being in quite miserable working conditions and being forced to classify disturbing examples of violence and hate without being properly sensitized to them. And lastly, there are the environmental costs. So if we hear about the plans to build even bigger data centers and server farms, we need to think about the resources that are being consumed to power all of this LLM ecosystem, from developing the models to hosting them. And then finally, we have some suggestions for further readings on the different uses of LLMs in computational social science. And again, not representative, but just a selection that we think makes sense in the context of what we have been talking about today. And with that, I hope that Gabriela is able to take over again.
And then now, very briefly, I also want to give you some information of what we, like GESIS, can do to help you integrate LLMs in your research workflow in terms of services available. And the first service is the GESIS Guides to Digital Behavioral Data, which is basically a publication series that offers expertise and structured overviews on computational methods, including LLMs. We have different type of guides, and I will give you one example, a couple of examples about LLMs in the next slide. It's a new service, so that we keep on adding new guides on various topics, and you can find them all like here. And specifically about LLMs, there is one guide that will be published very soon, I'm told, in the next weeks, which is exactly what I promised you in the beginning. Like, it's an overview of large language models for social and behavioral scientists, which reviews the essential concepts for LLMs, what the different LLM types are there, and what you should do. How can you select the one that you want for your task? And what are the challenges and risks? And then coming like a little bit later in the next months, we also have a guide on how to talk to LLMs. Basically, it's a guide about prompting techniques. And again, there are terminology, examples, and also word of cautions, for example, about privacy or hallucination. So keep checking the guides page, because these guides will be there soon, and they will be very useful for building your research plans with LLMs. And once you have done that, the next service that you can consult will be the Methods Hub, which is a collaborative online platform where, in general, not just LLM researchers can discover, share, and disseminate their methods. Contains methods, so software, R or Python, to support researchers in different steps of their work cycle. For example, methods to identify bias in LLM representation. This is something that we spoke about today. Tutorials, which are really learning materials in the form of notebooks that get you started with the methods. For example, you will find there a tutorial on text classification with LLMs. An interactive environment to the extent this is like possible for the methods being discussed. Again, we'll go public on July 2025, but you can learn more about it in the page here, or you can also write a mail to the Methods Hub team. Last but not least service is consulting on computational social science methods and digital behavioral data. Here, and you can use the form at the link that we put here. You have a service that basically puts you in contact with experts that at GASES deal with these methods and at different steps of the research cycle, not just LLMs, but for example, consultation requests that we have received and were related to LLMs in the past year were about instruction tuning or using LLMs to summarize open-ended survey questions, which is a task that I think many of you can relate to. And then basically, like, you get to talk to someone for half an hour at least, and you can get some initial guidance, which is always very useful. And also, most importantly, like, this talk is part of the Data Lover Week, and of course we all love data. And beside the services that we already mentioned, there are so many services at GASES to collect data. Also the app kit, the panel DBD, the web tracking, and so on and so forth. And thanks for your attention, and sorry if we extended a bit.